For today's remote lesson, you'll need this States of Matter Notes worksheet. At the top, it says States of Matter Notes. You'll need that today. You'll also need your workbook. So this workbook that you got last week, you'll need that. And you'll need a pen or pencil. I suggest a pencil. I'll be using this purple marker today, and a couple of other markers, just so that you can see my writing better in the video, but you should try to use a pencil in case you make any mistakes. For the start of our notes, you should open your workbook to page 11. On page 11, you'll see some information about the properties of states of matter. It's a little difficult for me to put my workbook and my notes in the same area. So this is my workbook. This is page 11, so you should also turn to page 11. This information here is the same information that's on my screen over here. So I'm using the online workbook on this side of my screen. You can follow along in your workbook as well as on the screen. So I'm going to take my workbook away since I have the electronic workbook up on the left. We're going to start filling in this chart with information about the three different states of matter. We're going to start with solids, and then we'll move to liquids and gases. For the shape of solids, I'm going to check in the text to see if there's information about the shape of solids. Our workbook says, a solid is a state of matter with a definite shape and volume. Moving a solid from place to place or placing it in a different container does not change its volume or its shape. Solids are difficult to compress or squeeze into a smaller volume. I've highlighted a part of a sentence in those notes. That part of the sentence says, solid is a state of matter with a definite shape and volume. In my notes, I'm going to zoom in just a little bit. In my notes, in the shape box under solid, I'm going to write the word definite. We can think of the word definite as meaning unchanged. So if you take a solid out of one container and put it in a different container, the shape will remain unchanged or definite. The text also tells us that the volume of a solid is definite. And again, that means unchanged. We're going to come back to the illustration and other information boxes in a moment. So I'm going to slide this over and we'll fill in information about liquids. Our text says, a liquid is a state of matter with a definite volume, but not a definite shape. Liquids can flow between containers. Moving a liquid substance from place to place or placing it in a different container does not change its volume, but does change its shape. Liquids are also difficult to compress. I highlighted a sentence in that paragraph as well. The highlighted sentence says, a liquid is a state of matter with a definite volume, but not a definite shape. So this says not a definite shape. So for shape of liquids, I'm going to write not definite. And I'm also going to include in parentheses that it can change. So I can take water from a round container and put it in a square container and the shape will change. However, the volume is definite. If I have 100 milliliters of water, no matter what container I put it in, I will still have 100 milliliters. The last column we're going to work in for now is the gas column. We'll save illustration and information about liquids for a moment. The last paragraph in the workbook says, a gas is a state of matter without a definite shape or a definite volume. Gases can flow between containers. Moving a gas from container to container changes its volume and its shape. Gases are easy to compress. Both gases and liquids are fluids because they can flow from one container to another. In the highlighted section of that paragraph, we have a gas is a state of matter without a definite shape or a definite volume. In my shape and volume boxes, I'm going to write that information. So again, shape is not defined or not definite. That means it can change. And we're also told that the gas has, in terms of its volume, is not defined or not definite. Okay, now I would like you to turn your workbook to page 14. I'm going to continue to use the electronic one, but page 14 looks like this. This is page 14 in your workbook. That's the table that we're going to be looking at. In the electronic version, it looks like this. So you'll notice they're pretty much the same, just mine is a little skinnier, so the words are a little more condensed, but it's the same information. On my note sheet, I'm going to go back to solids, and I'm going to work on that illustration. Based on the table in your workbook or on the screen, the solid looks like a cube. In my beaker here, I'm going to draw something that looks similar to that cube. It's okay if it's not perfect. You can try to copy the image as best you can. I'm going to leave mine two-dimensional. So I have just a little cube sitting in there in my beaker, and for the other information, I'm going to record the same exact information that is in the table on the screen. So particles in a solid are very close together. So they're very close to one another, and they're rigid. So they're in a rigid structure. Also, the particles are vibrating in the space. So particles vibrate in place. Even though we look at a solid and it doesn't look like it's actually moving, those individual little particles are actually moving. I'm going to draw just a few kind of motion symbols around that solid to represent that the particles are still moving. Moving on to liquids. Liquids is in the middle. For my diagram here, I'm going to try to copy that picture from the workbook. So these particles are moving around and they're kind of filling that space. In the other information section, I'm going to copy the same information from the workbook. It says particles are close to each other. I notice that they are not quite as close as the particles in the solid though. You'll notice there are some spaces here. In the solid, everything is really packed closely together. Particles in a liquid move around randomly. While they're moving around randomly, they're bumping into each other. Your workbook says they can collide with each other. And I'm going to put some motion symbols. I'm going to add a few extra ones to represent that they're moving more than the particles in the solid. And then last but not least, we have the gas column again. For the gas, the particles are moving around much more than in the liquid. I'm going to draw these very far apart. And I'm even going to draw some of these particles outside. If the gas is in a container that does not have a lid, sometimes the gas can come out of that container. I'm also going to record the other information that's listed in the workbook. So we have particles are widely spaced. And you can see that compared to the liquid, the gas molecules are very far apart, and especially in comparison to the particles in the solid. So each phase of matter, or each state of matter, the particles have gotten further away. And then last, the particles in a gas move around randomly at high speeds. The last thing I'm going to do is add a few of those motion kind of symbols around my particles. And then my notes are all set for when I return to class on Monday. I will take a picture of this and put it on the website, but you can always go back and watch certain parts of the video that you might have missed.